Good morning. Today we are going to start next bit of this chapter, that is Cauchy's mean value theorem. A real valued function f of x and g of x defined in interval AB where f of x and g of x are continuous in the closed interval AB and f of x and g of x are differentiable in open interval AB if g dash of x is not equal to 0, then there exists one value C belongs to interval AB such that f dash of C divided by g dash of C is equal to f of B minus f of A divided by g of B minus g of B. So here it is the statement of Cauchy's mean value theorem. A real valued function f of x and g of x defined in the closed interval AB where g dash of x is not equal to 0, then there exists one value C which belongs to open interval AB such that f dash of C divided by g dash of C is equal to f of B minus f of A divided by g of B minus g of A, where f of x and g of x are continuous in closed interval AB, as well f of x and g of x are differentiable in open interval AB. Now by using this statement, we are solving examples verifying the Cauchy's mean value theorem. So here we are solving first example. Verify Cauchy's mean value theorem for log x and 1 upon x, where x belongs to okay. So let us start to solve this. Now given functions are log x and 1 upon x. So consider f of x is equal to log x, g of x is equal to 1 upon x. Now differentiate it. Derivative of f of x, that is f dash of x, which is equal to derivative of log x 1 upon x, then g of x, derivative of g of x, that is g dash of x, which is equal to 1 upon x, derivative of 1 upon x, that is minus 1 upon x square. Therefore f of x and g of x are continuous in given interval. Second condition, f of x and g of x are differentiable in the interval 1e. Interval is given here 1e. So here it is closed interval 1. Here g dash of x is not equal to 0. Look at this, minus 1 upon x square. If you are keeping that 1 and e, you will get that not equal to 0. Then there exists c belongs to the interval 1e such that f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. Suppose here it is a statement, consider as first expression. Now interval is 1e, so here a is equal to 1 and b is equal to e, so that f of x is equal to log x, f of x is equal to log x. Therefore f of 1 is equal to log 1 and log 1 is equal to 0. Then put x is equal to, that is b, f of b. Consider that f of b. So f of e is equal to log e and log e is equal to 1. Okay. Now g of x. G of x is equal to, we have 1 upon x. So g of 1 is equal to 1 and g of e is equal to 1 upon e. Okay. After this, as we have f dash of c and g dash of c, so we are replacing that x by c. Therefore, we are getting that f dash of c. F dash of c is equal to f of x. What is f of x is that? F of x is log x and f dash of x is equal to 1 upon x. So replace that x by c. And similarly, g dash of x, that is equal to minus 1 upon x square. So it will be minus 1 upon c square. Therefore, we are getting that equation as 1 by c, that is f dash of c divided by minus 1 upon c square is equal to f of b. F of b, that is 1 and f of a, that is 0, divided by g of b, that is 1 upon e minus g of a, that is 1. Okay. So here 1 upon c divided by minus 1 upon c square, it gives 1 by c into minus c square, which is equal to 1 minus 0, that is 1, divided by, taking LCM, so it will be minus 1 minus e divided by e. Therefore here minus c is equal to e divided by 1 minus e. Multiplying throughout this equation by minus, so it will be c is equal to e divided by e minus 1. Okay. So here we have c is equal to e upon e minus 1. Put the value of e. So as we have the value of e, that is 2.72 divided by 2.72 minus 1. And here 2.72 divided by 2.72 minus 1, that gives 1.72. Calculate this, 2.72 divided by 1.72. What we are getting here?
1.58.
Yes, it is 1.58. And 1.58 belongs to 1, that interval 1 and e, isn't it? That's 1.58 lies in between these two endpoints, 1 and E. Hence, Cauchy's mean value theorem is verified. Okay? Everyone understood this?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am,
Ah,
f dash of c is equal to 1 by c. तिथून स्टेप जरा 2 स्टेप समजले नाहीत मॅम.
f dash of c.
इज इक्वल टू 1 by c आहे ना.
हा.
ते 2 स्टेप समजले नाहीत.
This first one. इथे काय
हा आणि
करायचं आपण
second.
कॉचीज मीन व्हॅल्यू थेरम आपल्याला व्हेरीफाय करायचंय. स्टेटमेंट बघा इथं काय आहे अगोदर. जस्ट अ मिनिट. हा. G dash of x is not equal to 0, then there exists one value c which belongs to AB such that f dash of c divided by g dash of c means here x we are replacing by c. x is equal to c मिळणार इथं आपल्याला एक पर्टिक्युलर पॉइंट मिळतो, वन व्हॅल्यू मिळते तिथं. सो हियर वी आर रिप्लेसिंग जस्ट c बाय x बाय c. फक्त या ठिकाणी c घेतला इथं. हा एक पॉइंट आपल्याला फाइंड आउट करायचा आहे c. तो त्या ठिकाणी मिळतो जी डॅश ऑफ एक्स इज नॉट इक्वल टू 0 असेल तर, कारण जी डॅश ऑफ एक्स या ठिकाणी नॉट इक्वल टू 0 येणार आहे. -1/x². या दोन्ही एंड पॉइंट साठी तिथं 0 मिळणारच नाही आपल्याला. नॉट इक्वल टू 0 आहे. isn't it? So we are getting that point C which belongs to the interval 1e. Got it?
येस मॅम, गॉट इट.
त्या ठिकाणी x च्या ऐवजी आपण c पुट केलेला आणि तो फॉर्म्युला मध्ये ही व्हॅल्यू पुट केली. नेक्स्ट एक्झाम्पल. Going for second example. Verify Cauchy's mean value theorem. Cauchy's mean value theorem for square root of x plus 9 and root x where x belongs to 0 and 16. So let us consider f of x. First value, f of x is equal to square root of x plus 9 and g of x is equal to root x. First differentiate it. Then f dash of x is equal to 1 upon 2 into root x plus 9 and g dash of x is equal to 1 divided by 2 into root x. Okay. Now here we can say that f of x and g of x are continuous in the interval a to b, that is 0 to 16. And second point, we can say that f of x and g of x are differentiable in interval 0 16. Okay. So here these two conditions are satisfied. Then g dash of x is not equal to 0. Look at this, 1 upon 2 into root x. 1 upon 2 into root x. या ठिकाणी आपल्याला g dash of x is not equal to 0 हे consider केलंय. There exists c belongs to 0 and 16. C belongs to 0 and 16 such that f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. So put that values here. First, we are taking that f of b. F of b means here f of x is equal to, we have root x plus 9. Then f of a, that is f of 0. What we are getting here? Root 0 plus 9. Root 9. And root 9 is equal to, we are taking that 3. Then g of x. G of x is equal to, we have root x. So first we are taking that g of 0 is equal to 0 and g of 16. G of 16.
मॅम
Just
16 राहील.
या ठिकाणी 16 चा राहिला. ओके. G of 16 is equal to, या ठिकाणी रूट 16 मीन्स 4. आता या ठिकाणी g of हा इथं राहिला ना आपला. So f of 16 is equal to root 16 plus 9 is equal to root 25, which is equal to 5. ओके. आता ह्या व्हॅल्यू सगळ्या पुट करूयात आपण. f dash of c काय येते बघा. सो f dash of c is equal to 1 upon 2 into root c plus 9 and g dash of c is equal to 1 upon 2 into root c. Put करा ते value तिथे आता. So by putting that value, f dash of c काय बघा इथं 1 upon 2 into root c plus 9 divided by 1 upon root c is equal to f of b is equal to 5. Then f of a is equal to 3 minus 3 divided by g of a 0 and g of b 4. So 4 minus 0. So 1 upon 2 into root c plus 9 into root c is equal to 5 minus 3, 2 divided by 4. बरोबर आहे ना? 2 कॅन्सल होईल ना, तर 2 इथं 2 आहे. 2 root. Okay. So 2 cancel. Root c divided by root c plus 9 na, is equal to 1 upon 2. Tell me that now. What will be the answer? Root c divided by root c plus 9. c ची व्हॅल्यू कशी काढणार? Look at this. Simplifying the term, a cross multiplication करूयात. So 2 into root c is equal to root c plus 9. Squaring on both sides. Square it on both sides. We get 4 into c is equal to c plus 9. Therefore 4c is equal to c plus 9. So 4c minus c is equal to 9. 3c is equal to 9. Therefore c is equal to 9 divided by 3, and hence we are getting the value of c, that is equal to 3. Okay, c is equal to 3 and c is equal to 3, which belongs to 0 to 16 na?
Yes, ma'am.
Yes.
Yes.
Here c belongs to 0 to 16. Hence Cauchy's mean value theorem verified. Okay. प्रत्येकाने समजलं एक्झाम्पल?
Yes, ma'am.
Yes, madam.
काही कन्फ्युजन आहे याच्यामध्ये? Is there any confusion? नाउ नेक्स्ट वन मला सॉल्व करायचं आहे आता. नेक्स्ट एक्झाम्पल तुम्हाला सांगते मी तसं. f of x is equal to e raised to x and g of x is equal to e raised to minus x for the interval 0 to 1. So verify third one, no? Verify CMVT for f of x is equal to e raised to x and g of x is equal to e raised to minus x where x belongs to 0 to 1. आता हे एक्झाम्पल तुम्हाला सॉल्व करायचे आहे. प्लीज गो अहेड. एव्हरीवन प्लीज. Yes, please tell me how we are solving it. Step by step. Already it is given f of x is equal to e raised to x. G of x is equal to e raised to minus x. Then f dash of x is equal to e raised to x. G dash of x is equal to minus e raised to minus x. So we can say that f of x and g of x are continuous in given interval. Okay. Second point, f of x and g of x are differentiable in open interval 0 to 1, where g dash of x is not equal to 0, then there exists c which belongs to 0 to 1 such that f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. Okay. So calculate that first. F of 0, that is f of a. Here a is equal to 0 and b is equal to 1. F of 0 is equal to e raised to 0.
1.
E raised to 0.
1.
f of 0 is equal to e raised to 0 is equal to 1. Then f of 1, which is equal to e raised to 1 is equal to e. Similarly, g of 0 is equal to e raised to minus 0, that is e raised to 0 is equal to 1, and g of 1, which is equal to minus e raised to minus 1, which is equal to minus 1 upon e na. Is it okay? G of p, that is g of 1 minus e raised to minus 1, e raised to minus 1, it can be put as 1 upon e. Therefore, f dash of c, f dash of c means e raised to c divided by minus e raised to minus c is equal to f of b, that is equal to e minus 1 divided by g of b minus 1 upon e minus 1. Now simplify it. Minus e raised to minus c divided by 1 upon e raised to c is equal to e minus 1 divided by minus 1 minus e minus 1 minus e divided by e. So here we are getting that 1 upon e, then e raised to 2c na, is equal to e into e minus 1 divided by, हा मायनस जर कॉमन काढला तर याच्यामध्ये मिळेल आपल्याला, हा मायनस आहे हा प्लस होणार, मायनस ने मल्टिप्लाय केलं तर इथे काय येईल बघा, हा प्लस असेल ना, हा प्लस आपला हा असं असणार आहे 1 अपॉन ई मायनस 1, हा इथं प्लस असणार आहे, मग मायनस जर कॉमन काढलं तर मायनस 1 प्लस ई डिवाइडेड बाय ई मीन्स हियर
G of 1 by येणार ना. G of 1 by
जी ऑफ 1
1 by येणार.
हा 1 अपॉन ई येणार, मायनस ऑलरेडी आहे ना तिथं, जी ऑफ सॉरी इथं जी ऑफ ई मायनस 1 अपॉन मायनस आपण जी डॅश घेतले, सॉरी
हा.
1 असणार आहे, प्लस असणार आहे, सॉरी इट इज प्लस. सो 1 मायनस ई डिवायडेड बाय ई. मग आता इथे जर मायनस कॉमन काढलं आपण तर ई मायनस 1 असेल आपला. ओके, सो मायनस मायनस कॅन्सल, ई रेस टू 2c इज इक्वल टू ई. देअरफॉर आता ई रेस टू 2c आणि इज इक्वल टू ई आहे, मग आता पुढे काय करायचं सांगा.
2c equal to 1.
2c
2
Equal to 1.
दोन्हीकडचे लॉग,
2c equal to 1.
दोन्हीकडचे लॉग जर घेतलं, टेकिंग लॉग ऑन बोथ साइड, देअरफॉर 2c इज इक्वल टू लॉग ई, दॅट इज 1.
मॅम बेस सेम आहे ना.
हो ना, मग 2c इज इक्वल टू 1 आला ना,
मग 2
तेच म्हणते ना, 2c इज इक्वल टू 1 आला, बरोबर आहे ना.
हा मॅम.
फॉर कंपेअर करतोय, so 2c is equal to 1, therefore c is equal to 1 by 2, and c is equal to 1 by 2 lies in between 0 and 1, isn't it? So here c belongs to the interval 0 to 1, hence CMVT verified. Okay, now we are going for the next one, next example. Verify. Verify Cauchy's mean value theorem for 2x square plus 1, 2x square plus 1 and 3x plus 4 in the interval 1 to 4. Okay, now solve it. Here f of x is equal to 2x square plus 1. G of x is equal to 3x plus 4. Differentiate it. Then f dash of x is equal to derivative of 2x square plus 1, that is 4x, and derivative of g of x, that is g dash of x, is equal to 3. So we can say that f of x and g of x are continuous and in given interval 1 to 4, and f of x, g of x are differentiable in given interval. Okay, then g dash of x is equal to is not equal to 0. Here g dash of x is not equal to 0. Then there exists c which belongs to the interval 1 to 4 such that f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of p minus g of a. Okay, which is equal to f of b. आता इथे कॅल्क्युलेट करूयात आपण पहिल्यांदा. f of x कन्सिडर करा. So f of x is equal to 2x square plus 1. Here a is equal to 1. So f of 1 is equal to 2 plus 1, which is equal to 3. Here it is f of a. Then f of b for 4. 2 into 4 square. 16 into 2. 32 plus 1.
32.
It is 33. Here it is f of b. Then g of x is equal to 3x plus 4. So first g of 1 is equal to 3 plus 4, which is equal to 7. G of a. G of b, that is 4. 3 into 4. 12 plus 4 is equal to 16. Here it is g of b. Now f dash of c. So f dash of c, that is 4c. 4c divided by g dash of c, that is simply 3, is equal to f of b 33
33.
minus f of a 3 divided by g of b 16 minus g of a, that is 7, which is equal to 33 minus 3, 30. 16 minus 7, it is 9. Therefore 4c is equal to 30 into 3 divided by 9. Calculate it. 4c is equal to 90 divided by 9, which is equal to 90 divided by 9, that is 10, and hence 4c is equal to 10. So c is equal to 10 divided by 4. Dividing by 2, we get that 5 divided by 2, and c is equal to 5 divided by 2. Whether it is it lies in between 1 to 4.
Yes, ma'am.
Yes, ma'am.
Yes. Therefore, we can say that C belongs to the interval 0 to, sorry, 1 to 4, no? It is 1 to 4. Belongs to the interval 1 to 4. Hence, Cauchy's mean value theorem verified. Okay. Now after this, next one, next example, sin x and cos x in between 0 to pi by 2. आता हे एक्झाम्पल मात्र तुम्हाला सॉल्व्ह करायचं आहे. मी एकही स्टेप सांगणार नाही, ते तुम्ही सांगायचे मला. Here f of x, verify Cauchy's mean value theorem for f of x is equal to sin x and g of x is equal to cos x, where x belongs to, x belongs to the interval 0 to pi by 2. Chalo, let us start. Is equal to sin x, g of x is equal to cos x. Just tell me that answer.
Ma'am, c equal to pi by 4.
प्रत्येकांचा आन्सर आला ते?
Yes, ma'am.
Okay. चलो सॉल्व करा. सांगा आता कोण सांगेल मला आन्सर.
C equal to pi by 4.
ओके, C इज इक्वल टू 5/4 ना. ओके, सॉल्व करूयात आपण इथं. f of x is equal to sin x, g of x is equal to cos x. Then taking derivative of f of x, that is f dash of x, which is equal to derivative of sin x,
Cos x.
cos x. Then g dash of x is equal to
Minus.
minus sin x.
sin x. Okay. Now, by using these two derivatives, we can say डेरिव्हेटिव्ह मिळतं म्हणजे तिथं आपलं लिमिट एक्झिस्ट होतं. लिमिट एक्झिस्ट होते म्हणजे ते फंक्शन कंटिन्युअस आहे असं म्हणतोय. ओके, सो वी कॅन से दॅट f of x and g of x, f of x and g of x are continuous in given interval 0 to pi by 2. Okay, and after that, second condition, f of x and g of x are differentiable in 0 to pi by 2. Okay, here g dash of x is not equal to 0. Then there exists c which belongs to the interval 0 to pi by 2 such that f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. Okay, which is equal to f of b, put that sine 0 and sine pi by 2. What is the value of sine pi by 2? That is 1 minus sine 0, 0
C.
divided by g of b cos pi by 2
0.
0.
minus cos
1.
0, that is 1. Now f dash of c, that is cos c
Cos C
divided by minus.
minus sin C. Minus sin C.
Okay, therefore cos c divided by minus sin c is equal to 1 divided by minus 1. दोन्हीकडचा minus 1 गेला. So cos c divided by sin c is equal to 1 upon 1. Tell me that.
Cot C is equal to 1.
Cos c is equal to 1. With 1 upon sin c.
Cot C.
Yes, cos upon sin. That is cot c is equal to 1. Therefore, c is equal to cot inverse of 1. And cot inverse of 1 means 1 upon tan inverse of 1.
Pi by
That is
4.
pi by 4. So c is equal to pi by 4. And pi by 4 lies in between 0 to pi by 2. Okay. So we can say that Cauchy's mean value theorem is verified. Now after that, last one example. Almost we have completed that all. Okay. ठीक आहे, हे सगळ्यांना एक्झाम्पल समजले. कॉचीज मीन व्हॅल्यू सगळ्यांना व्यवस्थित समजला.
Yes,
Yes.
Yes, ma'am.
Now after this we are going to discuss MCQs again. Just
Ma'am.
we have solved some all examples of that MPT. I'm not getting that MCQ booklet here. Assignment सगळ्यांनी सॉल्व केलेत का?
Yes, ma'am.
ज्यांनी ज्यांनी सॉल्व केलेला आहे असाइनमेंट त्यांनी सगळ्यांनी अपलोड करायचे, कारण तुमचे मार्क्स आपल्याला तिथे द्यायचे आहेत असाइनमेंट. त्यामुळे सगळ्यांनी जेवढे आपले PDF केलेत असाइनमेंटचे सगळ्यांना मी एक लिंक पाठवलेली आहे, त्या लिंक वर जाऊन तिथे अपलोड करायचं असाइनमेंट लिंक वर जाऊन. सो प्लीज डू दॅट टुडे इटसेल्फ. Today is the last date for that. And one more thing I want to discuss with you, that is about scholarship. I am going to end this meeting here only. Thank you all of you.